Okay, good morning everyone. I hope you are fresh in the morning and eager to hear some new things about front-end related topics, JavaScript related topics. For myself, I would say that I'm still a bit tired for nearly 24-hour trip from Macedonia. This is a small country in Europe. And I'm here to talk about Angular reactivity in a nutshell. So in one sentence, what we're going to cover today is a series of 3 RFCs that the Angular core team has made in order to make the framework better, more performant, and more reactive. So first is this new control flow. The second one is the deferred views. And the third one is the Angular signals, and this is basically the core part of the reactivity. So before we start, 2 things. About myself, so as announced, I am Blagoj, I work at etc. And this rather long job title wants to say that I have a couple of years of experience in applications mainly revolving around increased security during online payments. The easiest way to describe me is via 3 things that I love doing, and this is traveling, running, and last but not least, coding. And before we start, again, a bit familiarizing with the audience to see how much of you have at least heard about these concepts that I mentioned previously. So the new control flow in Angular, the deferred views, or the signals. Okay, nice. And how many of you have at least had a basic hands-on for these things? Try it? Okay, so you're in the right place. Here we will do a bit of a deep diving here. So I used to try this on a demo shop application, and this would be also my experiences, what I encountered during the tryout. So without further ado, starting with the new control flow. Why is this new control flow introduced? You would hear to have less bundle sizes or to be more performant. But in this case, if we take a look at the results from the benchmarks, you can see that the bundle size is a bit negligible comparing this control flow. And also from the benchmark, we can see some operations on millions of rows. And this is somewhat not convincing. So I found one slide from an article from Enea Yaholari. You may know him. He is a big enthusiast and Angular evangelist. So here, this is the best slide showing that the new flow is better. Because if you see in the upper picture, this refresh view with the current approach took 1.49 milliseconds. And in the bottom picture, with the new control flow, 0.82. This is like 45% increase, meaning this is a big argument to start switching to the new control flow. One other thing is that with this new flow, the variables that are within are into a reactive context, meaning that these are not subject to change detection. We will take a look at this a bit later. And this third thing, which is not from a functional improvement, but is a readability, we will see in the examples that this is less verbose and more like JavaScript. So we have mainly 3 things, the if, the for, and the switch. Starting with the if. So if you wanted to declare if-else block with the current approach, you have this verbose ng if. Then you need to declare a template reference variable, and within an ng template to define what value will be displayed into the else block. As opposed to this, with the new control flow, we have this add syntax, and then we say add if flag, and then add else. So this is way more intuitive. Similarly, with the switch, so we had the switch, case, and default. And here we have add switch, add case, add default, so definitely more readable. The last thing is about the looping. So we have the ng4, and on the right-hand side, we have the add for syntax. Here, there are a bit more changes, mainly with this. So in case your array is empty and you need to show some fallback content, with the old approach, you had to actually do an ngIf to check the length of the array. And in the new approach, we have this empty block. So this is now contained within the same for statement. And then this one other thing, this is like the track by part. So this was present previously, but it wasn't enforced. Track by is needed for optimization purposes. If you're just looping through an array, then you do not need it. But if you do some modifications, then the framework needs to count the minimum modifications in order to do this. But in order not to do a complete mess up, it needs to uniquely identify these objects. So you could use ID if it is a complex object, reference if it is a primitive, or to fall back with this index as a last resort if there isn't anything else. So this covers the first part. Now we go with the deferrable views. And before seeing at some examples, maybe just to show what a deferrable view is, because this deferring, whenever someone hears it, they associate it with lazy loading. And some even might get the idea that the deferred views are a replacement for the lazy loading. But the correct way of thinking about this is that the deferred views are complementary to the lazy loading, because you can lazy load a group of routes, you can lazy load a single component, and the deferred views are about lazy loading parts of component. So it goes beyond the component level. And this is needed in case you have some heavy UI components that there is some possibility that they might not get rendered or the user doesn't reach into the viewport. And for this optimization purposes, we have some options to actually make this better. There are two prerequisites for deferrable views. The first one is to use a standalone API, because if you still use the modular, then this will be pulled with the module, and it doesn't make sense to have deferred views. This shouldn't be a problem because standalone API is now the default, and I assume that also projects on older versions should need to move towards this. There is a schematic from the Angular team, so I think that this shouldn't be much big of a trouble, even if we're talking about a bigger code base. And the second thing is not to use these view child annotations. This is because whenever you use a view child, the Angular framework itself already controls the timing when it fetches the component. So if you use this in combination with the deferrable views, this would be a bigger intrusion within the framework. That's why this is forbidden from the beginning. And now some examples. So obviously we have this @deferred syntax. And here you see three things. You have a loading block, a placeholder, and an error. This loading and placeholder somehow can be confusing. Are they the same thing? Why we have some different annotations? And the reason is that previously, we control two things. This is important to know. We control when it gets displayed, rendered, but we also control when it gets loaded or fetched. So before this is even loaded, we have the placeholder block to show some kind of a fallback content in order to avoid this flickering. And then when the content starts to be fetched, the resource itself, then we display the loading block. So here we can control that after it is loaded for 200 milliseconds, this will be shown at least 200 milliseconds. And after the loading is finished, then we just display this up-heavy component. Otherwise, in case something goes wrong, then we have the error block just notifying us that the resource fetching didn't go as planned. Now, this defer has a couple of triggers, so you can really fine-grain control when things get rendered. The default one is on idle, so whenever the browser requests idle callback, they will start displaying it. There is also this on hover, and you can optionally provide a trigger. So if you just say on hover, this would mean that when you hover on the component in the DOM, then this will start to get loaded and rendered. But if you put a trigger, then here in this case, I have deliberately put this like 1500 pixels above. This means that when you scroll to this and then you hover on this button, then the block above will start to load. Also, there is this interaction, which usually means like user clicks. You can also put a fixed time delay, so to start loading after 3 seconds fixed. And also you don't need to interact with this trigger, but you can just say whenever the trigger comes into the viewport, then we will start loading this component. And there is this one other option. This is, you can use also a custom condition. In this case, we have this flag, and this might remind you of the if syntax, but there is a big difference because when you use the if, then you can actually undo the action, so you can detach or attach the view from the DOM, while into the deferred block, once this is loaded, of course, you cannot unload it. And here we see also the prefetch. So what I mentioned previously, we are controlling two things. One is when we load, and the other one is when we fetch. So this would mean that if we have some kind of a heavy component that we are not sure, or there is a high probability that it won't get rendered, or it will get rendered, let's say the second case, then you say, I don't need to wait until this starts loading, but rather I will prefetch immediately, and then eventually when this flag comes true, then I will display it immediately, because otherwise I would need to deal with this loading or the placeholder in order to prevent the flickering. And in this case, I'm saying, okay, this condition is initially false, I'm loading, I have everything prepared, and once this condition comes true, I just display it immediately. So this would be the way to go. You can choose either to use these placeholders or rather prefetch at some point. And with this, we have covered the deferrable views. I didn't go into too much details because this is really fine-grained. Modern browsers can handle fetching even of intensive resources, so that's why this is something that you might not use that often. On the other hand, the last thing, the signals, is something that you would definitely use. And before we start explaining what signals are, we need to explain what they are trying to solve. And this cannot be explained without touching the change detection, so how currently Angular is keeping the model and the view in sync. And this is with this library Zone.js. So this library Zone.js notifies that something happened, and then Angular just re-renders everything. I asked myself, how could it be possible at first when you are reading that the Zone.js couldn't tell us what actually happened? And the reason is because it does something called monkey patching. So monkey patching, the simplest explanation would be is that it overrides all possible methods from the browser API, and it just adds one code that notifies internally the Angular framework that something happened, and then Angular re-renders the things. What it does is that it forks the event loop. We know that in JavaScript, we have this event loop with mainly two queues, the microtasks and the macrotasks. And then this microtask has priority, meaning once you finish with a macrotask, you need to execute all of the microtasks before continuing to the next one. Well, Zone actually replicates this, and it handles its own queue, again, with micro and macrotasks. And first, what it does, we have this example with the set timeout. So these micro tasks are DOM manipulation or promise callbacks, while the macro tasks are something with IO operations or schedulers like set timeout and set interval. In this example, I have the set timeout. So this is added to the macro task queue. And then first, Zone.js is calling our own code. And afterwards, it needs to do the notification so that the framework re-renders everything. How it does this? First, it removes the task from the macro queue, and then, as I mentioned, all of the micro tasks run. And once this queue is empty, there is this subscribe block, so it listens to this event and calls the tick. And tick is the signal that the Angular framework under the hood listens to, and whenever it receives a tick, it just goes through the all internal views and re-renders everything. Needless to say, especially we have events like mouse click or mouse over, so it would be really resource consuming that we just re-render basically everything for this tiny change. So there needs to be a better way to do this. Apart from this, you are not supposed to read this, so this is just to display how much events are patched. You assume this is like a rather long list. This might even not be the complete list. And that's why the Zone.js itself was identified even a couple of years ago that it is one of the heaviest things, and it would be good to get rid of it. And in the good old days into the modules, getting rid of the Zone.js would be as simple as you just put ng-zone no-op. But what is the problem with this is that when you get rid of Zone.js, you need to do the change detection yourself. And this is something that you definitely don't need to do yourself, because you need to keep in state the model and the view for every single change that you do into your application. And this is what Angular was meant to do. So this needed to wait for better times, and these better times have come now with the introduction of signals. So what is a signal? It is, you can consider some kind of a light wrapper around variables, meaning that now all of the variables are some kind of a methods. Signal, if you're familiar with behavior subject, this is like really close to it. Basically, it holds the last value, and whenever someone asks for it, it gives it back. It's no surprise that we can initialize a signal with, let's say, some kind of a constructor into which we can supply an initial value, or we don't need to. In this case, the value will be, of course, undefined. And then we have set methods, update methods, if we need, if this is something related to the previous change, and we can get this by just putting parentheses. So now the framework itself can put event listener on these setter methods. This previously wasn't possible if it was an ordinary variable. And then, if all of the inputs are now signals instead of variables, then this would mean that each component would keep some kind of a reactive graph of its dependencies, and then the re-rendering of the only thing that changed is as simple as we know which signal has changed, we know which component have this signal as a dependency, so we will just apply the re-rendering to them, which is already much better than what the Angular framework does so far. And also, if we need to use this into the DOM, into the HTML part, again, we use this just with this parenthesis because this is how we get the signal value. Now, other thing that when we're discussing about the reactivity, the classic example are the ABCs, meaning that we have this standard example, we have two variables and we have the sum. And then if we now change the value of A to 10, what do I expect to be the value of C in the console, in this example? Can someone guess? You can shout also. 8, of course, because it's not reactive. And that's why we have computed signals, which basically, if we rewrite this example, and now we have C, which is computed from A and B, this means that now C is tracking the changes from A and B, and in this case, what do we expect that the value of C be? Yes. So this is mainly the purpose why the computed signals are here. What is one caveat is that you need to be careful when you're applying conditional logic in signals, because computed signals are lazily executed, meaning this is computed the first time it is requested. And one other thing is that during this computation, apart from retrieving the value, this also tracks which signals are dependencies, meaning that if it goes into one branch and there is a signal into the other one, it might not get detected. And this can lead to quite a dodgy code, hard to debug, hard to maintain. In this case, this is fine because when you are using signals into the branches, then the code is hardly to detect a flow. But things can get a lot messier if you are mixing ordinary variables with signals, which is in this case. So A is ordinary variable of 3, B is a signal, and then D is computed with an if-else block. And now the question is, if you have in mind what I mentioned to you, so the value is computed the first time it is requested, and the second one is that the dependencies are tracked. What do we expect that this locks? So we have first setting the A to 10, then we need to know the value of D, and then we set the value of B to 15. We expect two values, which would be those. So I would say this is the correct scenario. So here you would expect that because A is 10, and then we're requesting 10 is bigger than 5, so it's 10 plus 5, 15. And then we set B to 15, 10 plus 15, 25. So it's all good. But the problem is, what would happen if you just flip the order of these two commands? So what will happen if we first request D and then set A to 10 and B to 15? And then we will have a broken state because, as I mentioned, this D is computed, and in this case, because A is 3, so it's less than 5, it returns the 3 part, but also the problem is that it doesn't detect that B is a dependency. So when you set this B to 15 and A to 10, then in this case, D will again be 3. With this, the problem is that this block, basically the change of A, also that is important to mention, although it should be intuitive, since A is not a signal, again, this change of A to 10 is not tracked. So you need to be careful. One option is that if you really need to use complex branching, then you can just pre-compute the values with some statement like this.a. It's a bit weird, but on the other hand, either to use the signals or try to refactor the code so that it doesn't use that much of a complex logic when you're computing signals. Now, what kind of signals we have? This first one that we saw is a writable signal, meaning that it has a setter and getter methods. Also, we have computed. These ones are read-only signals, so it will throw an error if you try to write to it. Also, you can make a writable signal read-only if you use the sRead-only method. Of course, the other possibility is I mean, the other direction is not possible. So if you have a read-only signal, you cannot make it a writable. You need to create a new signal with the read-only as the initial value. And there is one other thing. This is the untracked signal, meaning that whenever you request this, you are saying do not count this as a dependency or neglect these changes. At first, it is a bit hard to imagine in which scenario you would need this, but later in the slides, I have one good use case for this that I will show. The next thing is that now that we're doing migration of all of the variables, we need to take into account all possibilities that we have in Angular. So far we just saw these ordinary variables, but remember that we have these input and output decorators, and now this also need to be migrated from variables to signals. And how would you do this? So since Angular 18, these have already been migrated, meaning we have an input signal, which is good to remember that is a read-only signal. Then this input can become required. So this is something similar as we had with the decorators. And we have a model signal. So a model signal, the initial purpose was to enable this two-way binding. So this is important into components, custom components, where you need just to have a bidirectional flow. But another thing for models is that if you know, for example, when we have input decorators, it can be that this variable can also be changed within the template or within locally in the JavaScript block. But since the input is read-only, this wouldn't be possible, and that's why one option would be to convert this to a model, and then we will just use one part of the direction when we initialize, but afterwards we are enabling the writing of the signal. So these are the two main use cases for the model signal. And also we have these outputs. Really, there isn't much here. I mean, under the hood, things are different, but from what you see or the means of usage, it would be the same as you would use these output decorators. Of course, whenever you use this into the template, this isn't anything special because the inputs are again signals, so you request this value with the parentheses. And also what is important is that when you are using model signals with this ng model directive, you need to pass the reference. But you wouldn't make this mistake of passing just the value because the compiler will inform you about this. And the last thing about the outputs, so no changes there. You just use this emit method, and then this is similar as the output decorator. So you just pass the value from the child outside to the parent. So computed signals were here in order, we have some kind of a dependency, and then we provide this value back. But there are some use cases into which we don't want to return a value inside a variable, but rather whenever some signal changes to do a side effect, no matter how complex it is one. And the most basic one is that we try to log in something. But what is, let's say, a limitation or a safeguard is that inside the effects, again, you cannot, by default, write to signals. Why is this so? It's because, I mean, if you know what you are doing, you can just say allow signal writes to true, and then this would be supported. But the problem is that in this case, we have the hand as a dependency, but also we're trying to set a value. And you can imagine that whenever you try to set this via the UI, then this value would be rewritten, meaning that we cannot change it, and this is a broken state. Things can get even worse if we're doing something like this. We are updating this value, but this value continuously changes. And this leads to an infinite loop, meaning that the value has changed, but it is a dependency, so the effect will run once again, the value will once again change, and then there is no way out of this. That's why I would assume that Angular didn't by default allow signal writes, but in case we have some places where we want to change completely unrelated signal, then we just say, okay, allow signal writes, and then I have the hand dependency, but there is this one safe hand, which is totally unrelated, that I would like to change. There are use cases like this, and it should be supported, because when we aren't using signals, we have these input setters, and then this is the possibility whenever the signal changes, just to do whatever we want. And the idea is that when we migrate to something else, it should be at least as good as it was previously. So this is the way to support those kind of scenarios. And if you remember previously, I told you that I would give one use case for the untracked signal. This seems kind of wrong, but it works. So if you see here, it's the same as on the left, except that now we do not have this allow signal writes true. However, we are doing a setter inside, and the compiler wouldn't complain. This is because we are saying to the compiler just to neglect these changes. So this set would be effective. However, this will not be considered either as a dependency or that we are doing this change. In short, we are lying the Angular framework about this, but it's something that is also an option. The last thing, this is rather advanced. Most probably we wouldn't use it, but for completeness I would mention. Effects are destroyed by default when the component is destroyed. However, you can intervene manually. So in case you want to do a manual cleanup, then you will just need to call this destroy method by yourself. And there is one other thing that might be of a good use is that when you destroy this component, in case you need to do additional cleanup by yourself, you can pass a callback function and then there do something either with a database, unsubscribe from observables and stuff like that. Again, mentioning, haven't used this so far, but there could be some edge case scenarios when this is needed, so it's good to know at least that it is supported. For these signal-based queries, so also we have view child, view children, content child, content children. So again, this is the same thing. So there are migrations that will actually enable this. So basically all of the scenarios are covered. Whether we are querying by a template reference variable or by a component itself, we have all of the possibilities already in for the signals. And it's no surprise how this is used within the TypeScript part. So again, just requesting the value by the parentheses, and then if it is an element ref, it goes with a native element. Otherwise, here, if it is a component, then you access its properties. So nothing more to see here. So this is another thing that is already implemented and is ready to use. Currently, I think these things are officially still in developer preview, but quite stable and good to use. Now some other things about this view children. So the good part is that previously there were some timing issues in case you might need to have this in the onInit part and not in the after view init. And there is one place where the value is first undefined and then it goes to the correct value that is fetched. And sometimes, I mean, I guess all of you have received at some point this dreadful error, expression changed after it has been checked. And in order to get past this, I mean, there are a couple of things you could do it the proper way just to delay something, or you say put set timeout. We saw previously set timeout is triggering the change detection because Angular is saying, I have finished with the changes, but I see that you are still trying to do something. I don't want to do it again. And with this set timeout, it's the same as you would say, okay, sudo do it. I know what I'm doing. And then you can put it like this. So you have this static flag to true, and then in the engine init, you would take it. And with the signals, because the value will eventually be there, we don't have change detection, so you won't have this error anymore. This is just a short list of the methods. So on the left-hand side, we have these lifecycle hooks that we know them now. And if you see here, the only things that are kept are the ng-on-init and ng-on-destroy. Everything else is more or less replaced with signals, apart from this after view init that is replaced with the after next render. So also this part is covered, but no one is talking about the elephant in the room still, and this is the forms. Because almost all applications have forms, currently the support for forms is just from community solutions. So I have seen this for the template-driven forms, although these are more rare. And there is this thing that I tried a lot, Tim the Shriver, with the reactive forms. However, this use case that we have with a lot of nested forms didn't prove such of a fit. There is some work done here with ng extension, again, Enea Holari, so he was ahead of Angular, and now with these later releases, there are official migrations to the input, output, and the queries. For the forms, I mean, according to the actual documentation, we would still need to wait, but I would say that in reasonable time on the roadmap, this has been defined, so it will be present. And let's assume that at some point we have this, so this is the last thing in order to completely migrate. And there are these two final touches that you would need to do. The first one is this polyfills array. So then you would need to remove the zone.js. And also you would need to add this, currently experimental, but hopefully in 2 major releases, it will be the zoneless change detection. And with that, you will have complete signals, and you would have, hopefully, a better and faster Angular application. So this is what I had to share. Thanks for your attention.